does it mean to solve a quadratic equation? Well, guys, all this really means is that we want to find the values of x that makes a function equal, that's not how you spell equal, okay, added the little t there. We want to make a function equal to 0, all right, guys? So we want to find the values of x that make a function equal to 0. That is true, actually, for how you solve any equation, is you set your function equal to 0. But quadratics are a little tricky because they have that x squared in there, so that messes with you a little bit, okay? And guys, so what this means when we're looking at a graph physically is this is where the parabola crosses the x-axis. Oops. All right, guys, so this is where your parabola crosses your x-axis, or this is when y is equal to 0. Those two things, okay? So it's your x-intercepts, and it's when y is equal to 0. All right, and so the way we can talk about this is we can talk about it, we call these 4 different names, all right? Now, some of these you should be familiar with because we talked about them a little bit last unit. We use this lovely acronym ROCKS because math rocks. The R stands for roots. If I ask you to find the root, I'm asking you to solve the quadratic equation. If I'm asking you to find the 0, I'm asking you to solve that quadratic equation. If I'm asking you to find the x-intercepts, that is the exact same thing as the roots and the zeros. I guess I should make that plural, zeros. And then the s, this is a little bit new, but it still makes it work because math still rocks. We have solutions. Do y'all feel good about that? So your roots, your zeros, your x-intercepts, and your solutions, guys, these are all where the graph hits the x-axis. All right, guys, so this is all where the graph hits that x-axis. Do y'all feel good about that? Or where it crosses the x-axis. It's all your x-intercepts, okay? And there's 3 different possible types or number of solutions that we can have. So what I'm going to do is I'm going to go ahead and draw some little axes right here so that we can have these on here. All right, so there's 3 different types. All right, guys. So I'll zoom in to this first one here. Okay, whoops, sorry. So what are the possible number of solutions to a quadratic equation? Well, guys, this is going to be your most common, all right? When you have a parabola that crosses your x-axis 2 times, how many solutions would we have? 2 solutions, or I'm going to call them roots this time. I could say 2 roots, I could say 2 zeros, I could say 2 solutions, 2 x-intercepts, but we have those there, okay? So this is probably your most common type of solutions here, okay? And then you also have a time where your vertex is right on the x-axis. So how many zeros would we have in this case, or how many solutions? Just 1. So this one would be 1 zero, or 1 solution, or 1 root. All right, guys, because it only crosses our x-axis 1 time. And that is when your vertex is right on the x-axis. Do y'all feel good about that? And then there are also some very lovely special circumstances where you have a graph and it never crosses the x-axis. So how many solutions do we have when that happens? You have, let me amend this. It is not no solutions. It is no real solutions. Okay, oops, sorry about that. There's no real solutions in this case. There are actually imaginary solutions, okay? There are such things as imaginary solutions. I know that sounds silly, but it is true. There are imaginary solutions, okay? And so it's no real solutions, or you can just say there's imaginary solutions. You could do it either way. Imaginary numbers are when you take the square root of a negative number, and we will not be doing that in algebra. You get to do that later in other maths. And I actually took an entire class in college, and all we did was imaginary numbers. It was called complex algebra. That's what we did all semester long. Super fun. Okay, so imaginary numbers, there are such thing as imaginary numbers for all of our imaginary friends to play with, okay? So here we go. So if we want to identify the solutions in these graphs, hopefully this is fairly easy. You can write these a couple different ways. All right, guys? So the first thing, if we want to identify our solutions, guys, then we want to, what are we looking for specifically? I'm going to zoom out a sec. If we want to identify solutions, guys, we want to find when y is equal to 0, or on a graph, we want to find the x-intercepts. Are you guys good with that? So we are going to look for our x-intercepts today. So on this lovely graph right here, I'm going to kind of zoom in on these two. And so what are my x-intercepts of this first graph right here, y'all? Let's see here. Yeah, what do we got, Abby? Yeah, we have negative 3, 0, and we have 0, 0. So guys, you could write it just like this, or you could write x equals negative 3 and x equals 0. You could write it two separate ways. All right, guys? You could write it as a point, or you can write it as values. All right? If it asks for the x-intercepts, write it as a point. If it asks for the solutions or the roots, you can write it as a value. Does that make sense, you guys? So if it asks for the x-intercepts, please give the ordered pair. But otherwise, you could write it either way. All right? What is going to be my solution on this second one here? We just have one, don't we? Isn't that wonderful? So what is my solution right here? Can you help me out, Miss Maria? Yes, ma'am. It is 2, 0. We could also say that x is equal to 2. You could write it either way. You do not have to write it both ways. You could write it either way. And guys, in this case, we only have one solution because my vertex is right on the x-axis. All right, guys? And then we're going to jump over here to our last graph. It looks like, how many solutions do we have right here, Miss Amari? We got 2. Can you tell me what they are?
0, 0, 3, 0.
Yes, ma'am. We got 0, 0, and we have 3 zeros. So you could also write that as x is equal to 0 or x is equal to 3. Do y'all feel good about that so far? Awesome. Identifying your solutions from a graph are probably the easiest thing that you will get to do this entire unit. You will have some homework problems where that's all I'm asking you to do is to identify it from a graph. Wonderful, right? Okay. Then we also can identify our solutions from a table. So guys, when we are identifying our solutions from a table, what are we looking for exactly? We want to find what? Find, yeah, when y is equal to 0. You want to find when your y is equal to 0. Okay? So we are going to look for that in our first table. So where is y equal to 0 in this first table right here? Negative 2, 0, and 2, 0. So we have negative 2, 0, and 2, 0. Or you could also write x is equal to negative 2. And sometimes, guys, you can write it as x equals negative 2 and 2. You can just write it as two separate commas because it's equal to two things. You will also see it like that, where it's equal to two values, all right? X is equal to negative 2 and 2, all right? And so on this particular problem, guys, what do you think the best wrong answer, if this was multiple choice, what do you think a really good wrong answer would be? The 0, negative 4. Now, this is not a solution, but what is this? This is your y-intercept. It's still an important point, but it is not a solution. Does that make sense, you guys? So this is your y-intercept. It's an important point, but it's not a solution. All right, y'all? So that I would just keep your eye out for that. All right? That would be the best wrong answer in this case right here. All right? So how are we going to identify our solution on this second table here? What is my solution on this second table? What do y'all see here? Good job. Okay, so Sophia, you said negative 5, 0, and I heard a couple other people as well. Are there any other solutions that we can look for? Okay, why not? Yeah, it only is on there one time. Also, y'all, what is special about this point? It's the vertex. So, guys, when your x-intercept is the vertex, you only have one solution. So if your x-intercept is the vertex, there's only one solution. All right, guys? So that's super important. There might be times where you type in a graph and only one of your zeros pops up on the table, but that's just because the other point is like a decimal or something. So it's only one solution when that x-intercept is a vertex. Do y'all feel good about that? All right, and last but certainly not least, let's look at this guy here. Where is my solution? When does y equal 0? Is y ever going to equal 0? Why not? Oh, because it goes down. Guys, this is our minimum value right here, right? So if that's your minimum, your vertex or your minimum value, if I actually sketched a little graph of this over on the side here, 0, negative 6, 1, 7, 2, 10, just real loose. Oh, if I graphed this, it would never hit my x-axis, right? So guys, there are no real solutions in this case, because y never was equal to 0. There's no x-intercepts. If there's no x-intercepts, there can be no real solutions. Do y'all feel good about that? So far. Awesome. Any questions for me? This first page is really nice. And I'm going to be honest, the second page is also pretty nice. All right? So we're going to go to our second page. We are still going to do this by graphing, but now instead of giving you a picture, I am going to give you an equation. So y'all, how would you recommend that we find our solution based on this equation? Do you guys have any recommendations for me? Put it in your calculator. I love it. All right, guys. So we're going to go here, and I'm going to go, I'm going to clear that out. So I'm going to say y equals 1/2 x squared minus 8. First of all, guys, what is the vertex going to be of this? I'm going to hit graph. Where is my vertex, y'all? 0, negative 8. So if we were thinking vertex form, so my vertex would be 0, negative 8. So I'm going to go ahead and write that just so I have it. So my vertex is that 0, negative 8. And then, y'all, I'm going to use my table to find my other points. All right, guys? So I'm going to use this lovely table to find the other points. So we had 0, negative 8. Then I'm going to do negative 2, negative 6, negative 4, 0. Lovely. my zeros are right there in my table. Are they not? They are. So I'm going to use these lovely points. I'm just going to draw a quick little sketch here. And guys, you can see very clearly from your table and from your graph that my two solutions, because we have how many solutions? We have two solutions. Oh, it kind of looks like a person smiling at us there. But guys, we have two solutions here. And my two solutions are going to be negative 4, 0 and 4, 0. Or you could also write it as x equals negative 4 and x equals 4. So it depends on what it is asking for. But guys, you could write it as those two separate things. Do y'all feel good about that? You can find that on your table. You can find it by looking at the graph. But this one is pretty clear, right? It's right on those marks, and we can go to our graph and we see negative 4, 0, and we can scroll down and we see that 4, 0 right there. Do y'all feel good about that so far? Yes? No? Cool. So for this particular one, guys, all you've got to do, is find your, the glare is so strong. So you guys can find your solutions from the calculator. So guys, for number 2, I want y'all to do that right now, where you literally just graph it and then find your solutions there, okay? So graph it on your calculator, and you're pretty lucky when you get these nice, clean solutions here. If you do not have a calculator, now is a great time to go get one. Okay, I'm going to try it without this. Lovely. I feel like it's harder to see. Nope. All right, so I'm going to go to my y equals. My vertex in this case would be, positive 2, 0. That would be my vertex. I'm going to find my other points. It's also going to open down because it's a negative. So I'm going to do negative x minus 2 squared. Graph. Cool. I'm going to go here and find some other points for me. So yes, my vertex is right at 2, 0. And then 1, negative 1. 0, negative 4. 3, negative 1. 4, negative 4. Oh, I'll also jump to this guy, just so I can have it. There we go. So I'm going to graph my little parabola here. I'm graphing it from the points in my table, and I can kind of see it. It's not a perfect parabola, but it's pretty good. So what is my solution on this number 2 right here, guys? What is my solution? Yeah. So you could write it as x equals 2, or you could write it as a point at 2, 0. And what do we notice? How many solutions do we have in this problem right here? We only have one solution because our x-intercept is going to be our solution. Do y'all feel pretty good about that? Okay. So now, guys, we are going to take a look at this, and we are going to see, we are going to find our solutions in the calculator. Okay, so guys, on this particular one, we found our solutions, but they were nice, clean, and easy solutions. You could find them really easily in the table. Okay, guys, on these next problems, they're not necessarily going to be clean and easy. They could be, but they might not necessarily be. So, guys, how you can find your solutions in the calculator, first of all, what you guys must know is that we are going to use some of our little second trace things. But, guys, your equation must be in standard form, okay? So standard form is going to be super important. That's that y equals x squared plus bx plus c. So guys, before I do anything else, so it must be in standard form like y equals, or it must be equal to 0. All right, y'all? So the first thing I want to do on numbers 3, 4, 5, and 6 is we're going to put all of these equations in standard form if they are not already in standard form. All right, y'all? So we're going to put all of these equations in standard form if they're not already there. So for number 3, let's take a look. Is number 3 in standard form? It is. Y equals, yeah, we're good. So number 3 is in standard form, so we're good. Is number 4 in standard form? No. So it has to either be y equals or it has to be equal to 0. So guys, I'm going to subtract that 2 so that we can get it equal to 0, and we are going to graph 2x squared minus 6 equals 0. Now it's in standard form. All right, guys, because it is equal to 0. Do y'all feel good about that? All right, let's look at number 5. Is number 5 in standard form? No. So we are going to subtract this 4x off of here to get that out of there so it can be equal to 0. But if I subtract it off the left, I got to subtract it off the right. Do I have an x to subtract it from? No, so I just got to put it in the middle there because it's sad and doesn't have anybody. So we are really going to be graphing x squared minus 4x plus 5 equals 0. Do y'all feel good about that? And the last one here on number 6, 3x squared minus 6x, or plus 6x equals 45. Is this in standard form? Nope. So we're going to have to subtract 45 from both sides. Are we really subtracting 45? We can't subtract it from 3x squared or 6x because those aren't like terms. So we can just write it as 3x squared plus 6x minus 45 equals 0. So these are my standard forms that I am graphing. Does that make sense, you guys? All right. And so now I'm going to show you actually three ways to graph this, okay? So the first thing you got to do is you got to make sure it's in standard form, okay? The second thing that you're going to do, that you will always do, is you will put the equation in y equals. You will do that always, all right? So let's do that. Even if we're going to go here, we're going to say y is equal to, I'm going to do number 3 with you guys, negative 2x squared. Whoops, forgot that. That's going to change your answer. If you do not type it in correctly, you will not get the right answer. So negative 2x squared plus 7x plus 15. I'm going to hit graph, and I want to see what this looks like. Okay, so this is a little bit of a bummer, isn't it? Because does that look like, how many solutions do we have for sure? We have 2, because it crosses the x-axis twice. But are they clean solutions? Well, one of them is, right? If we go to our table, what's one of my solutions going to be? 5, 0. We see one of my solutions is clean, but the other one is not. So y'all, we know one of my solutions is 5, 0, so I'm going to go ahead and put that here. Are y'all cool with that? Because I know I got one of them. All right? The other one, it's somewhere between negative 1 and negative 2. But we don't know exactly what it is. So guys, you can do 2 things here, okay? The first thing you can do, I'm going to kind of show y'all. The first option is you can do that second trace, and we are going to hit number 2, right? Which is the zeros. Do you guys remember doing that? We did that. We did this last unit. Where guys, you can go second trace. You can go down to number 2, and you can hit that 0 right there. But then you have to create your left boundary and your right boundary, and you have to do your guess, and then it gives you your 0. In this case, it's negative 1.5. Do y'all feel okay with that? So negative 1.5. So here, we got x equals negative 1.5, and then we also had x equals negative 5. That's where we got our positive 5. Now, guys, I would go ahead and rewrite that as a fraction. You do not have to. Look at what your answer is like. Does that make sense, guys? If all your answer choices are in fractions, convert it to fractions. If all of your answers are in decimals, leave it in decimals. I personally like fractions better. So I would make that negative 3/2 0, But guys, both of these options are totally acceptable. Does that make sense? They would be counted 100% correct. So let's review. So we went second trace. We did number 2 zeros. Then you have to do the left boundary, the right boundary, and you have to hit your guess, and then it gives you your 0. Do you guys remember doing that? And then the only thing is guys, if you have 2 weird zeros, then you have to repeat it. Does that make sense? You got to do it twice. You got to do it for both sides. In this case, we didn't really have to do it twice because we already knew that one was 5 0. But if we went over here, we could go second trace 0. Okay, I'm going to make my left boundary. Let's do it there. My right boundary is way on the other side. And then my guess is 5 0. So you have to repeat it. Okay, so second trace, number 2 zeros, left boundary, right boundary, guess. Okay, and then you do the whole thing and you repeat it, right? So you repeat it for the other one. So that's one option. But guys, some of y'all just aren't very good at the whole boundary situation, okay? I don't want to cause offense, but some of you guys, you're like, I don't get this, I'm not good at this. That's okay. So there's another thing you can do. You can put your equation in y equals, and then in y2, you can set it equal to 0. So guys, this is actually super cool. If you go to y2, you can set y2 equal to 0. And when you hit graph, it graphs that straight red line across there. Okay? And then, instead of second trace zeros, we are going to do second trace, and then we are going to use the intersection, okay? So we are going to go second trace because we want to see where the blue and the red intersect. Does that make sense? And all you have to do is you have to enter 3 times, and you have to make sure your cursor, when it says guess, is kind of close to the 0 you want. Okay? You hit that enter 3 times. Make sure your guess is close. And then, y'all, it gives you your intersection of negative 1.5. So, y'all, you can do it 2 separate ways with the second trace zeros or second trace intersections. But if you do it with the intersection, you have to make sure your y2 is equal to 0. I'm going to be honest, I actually prefer it this way because I don't have to do the left boundary and the right boundary thing, all right? I can do it, but it's easier not to, in my opinion. So I like it this way, but you have to make sure that you repeat those, really just these 2 steps. You repeat those 2 steps for both of your zeros. Does that make sense, y'all? Okay? And then lastly, I am going to show you one more method that you can do at home because you might not all have access to a graphing calculator at home, but you will have access to Desmos at home. All right, guys? So if you type in your equation, negative 2x squared plus 7x plus 15, y'all, and you also have access to Desmos on Star, guys, check it out. It literally just gives you your zeros. It actually gives you all your important points, all right? It gives you your vertex. If you, like, hover over it and click it, it, like, highlights all your x-intercepts for you. Now, guys, you will not have access to Desmos on your test, but you will have access to Desmos on your Star, and you will have access to Desmos for your homework. So this is a wonderful thing to do that, to see that there. All right, guys, so Desmos is a wonderful tool for you to see that. So what I want you guys to do is, now that we've solved numbers 4, 5, and 6 all for 0, I want you guys to practice putting these in your calculator and finding the solutions. All right, guys, I want you guys to practice putting those in your calculator and finding the solution. All right, guys, so hopefully you guys were able to see the following solutions here. We had negative 1.732. If you just had negative 1.7, that's okay. But especially with a repeating decimal, you want to go ahead and add a few more. And 1.732, if you also just did x equals negative 1.732 and x equals 1.732, that's okay. All right. Now on number 5, when we graph this, and so when we're looking at number 4 here, you can see, if I look at this number 4, guys, if you look at it on Desmos, it actually gives you your little values here, right there on Desmos, or you could have done, I personally prefer the intersection method on your graphing calculator, but we had negative 1.732 and 1.7320. For number 6, it was x squared minus 4x plus 5. So guys, were we ever going to have any solutions to that problem? No. So that is why on here we put no real solutions. Or, as one student said, there are only imaginary solutions. It's not an error. There are just no real solutions because it never crosses that x-axis. Okay? And then for number 6 here, these were actually clean solutions. So you could have found it just by looking at the graph, or you could have found it from the table, or you could have found it from the intersections here, okay? So when you're looking at this guy, there's 3x squared plus 6x minus 45. You saw that your solutions were negative 5, 0, and 3, 0. Do y'all feel good about that there on this one? Does anybody have any questions for me on how to find solutions from a graph? Do y'all feel pretty good about finding those solutions from a graph? Hopefully, you guys can do that. And guys, it's really not too bad. So now we are going to talk about what it's like to find solutions when we don't have a graph. When we are going to do this by factoring. Okay? So guys, you can pretty much always find your solutions by graphing. All right? But there will also be times where you have to find your solutions by factoring. Okay? And so the reason this works is because of this zero product property. And what the zero product property basically tells us is that if the product of two quantities is equal to 0, then at least one of the quantities must be equal to 0. So then at least one of the quantities must be equal to 0. Do y'all feel good about that? And so what this basically means, guys, is that if we have, I'm going to go with, I'm going to make up random letters, all right? H, because I'm a human ec, and let's do M, because I'm teaching math. So if we have H times M is equal to 0, all right? Yes. So guys, if H times M is equal to 0, then H must equal 0, or M must equal 0. Do y'all feel good about that? So one of those has to be equal to 0. That's our zero product property. Okay, now both of them could be equal to 0, but at least one of them's got to be equal to 0. And that works really, really great with our factoring here. Because guys, when we look at this, I would not be able to look at this and be able to tell you, ooh, if I plug in a 4 for my x, it's going to equal 0. That would be a lot of guessing and checking. Does that make sense, guys? And so we don't want to do that. And so we are going to factor it and then set each factor equal to 0. So guys, over here, the very first step, it says equation must be in standard form. So guys, standard form is ax squared plus bx plus c equals 0. And then, guys, I accidentally did this. It says factor using the box. Scratch that out. You guys don't use the box. You guys are honors. So just factor, all right? Can you just factor? Is that cool? Y'all are good with just factoring? Okay? So the second step is we're just going to factor. So let's factor 2x squared minus 9x minus 5. So how do we factor this lovely trinomial? What's our first step, y'all? Quick reminder, this was Unit 8. Yep, we do a times c, so we make our little x, right? So guys, what goes on the top of my x here? So negative 10, and then my b is negative 9. So what two numbers multiply to negative 10 but add up to negative 9? Negative 10 and 1. So those are our two lovely terms that we're going to use to split the middle. So I'm going to rewrite this as 2x squared minus 10x plus 1x minus 5. So that negative 9x, we just split that middle term up. Do y'all feel good about that? Is this ringing any bells? Okay. So then we want to factor by grouping here. So y'all, what can I take out of my first term right here? 2x. And what gets left behind? X minus 5. Are you guys good with that? Can I take anything out of the second one here? Just a 1. And I'm still left with an x minus 5. Are y'all cool with that? So my two factors are 2x plus 1 and x minus 5. Sorry, I forgot my parentheses here. So 2x plus 1 and x minus 5. All right? And that is equal to 0. So we just factored that trinomial. Do y'all feel good about that? So this is my factored form. So then, guys, our step 3 here says now we want to set each factor equal to 0. Now, how do I check to make sure that I did that correctly? Plug them both into the calculator, right? If I plug them both in, I make sure they're equal to each other, we're good. So now I want to set each factor equal to 0. So before we do that, I want to make sure I'm correct. So I'm going to go here, and I'm going to say 2x squared. I'm going to have to retype the whole thing. 2x squared minus 9x minus 5, and then 2x plus 1 times x minus 5. I'm just going to check myself because I want to make sure I'm finding the right solutions. Aha! They're the same. Oh, you can't really see that. Sorry. So I typed them both in the calculator. I hit graph, and they graphed right on top of each other, so we were good to go. So when they graphed, they went boom and boom. Do y'all feel good about that? Okay, so we know it's correct. So now I'm going to set each one of these equal to 0, because either 2x plus 1 must equal 0, or x minus 5 must equal 0. That's the only way we're going to get it equal to 0. So I'm going to say, okay, 2x plus 1 is equal to 0. Well, guys, how do I solve for x? What am I going to do here? How do I find what x is? Any ideas? Will, do you have any ideas? How do I solve for x? This is like 8th grade pre-algebra stuff. How am I going to find the value of x here? I'm not going to repeat my question a 4th time. Okay? So how would I solve for x? We're going to ask someone else. Awesome. All right, Alex, can you help me out? There we go. We subtract 1. So you said negative 1. But what we want to do, Will, is we want to subtract that 1, right? Now I'm going to let Will redeem himself here. We got 2x equals negative 1. What do I need to do now, sir, to solve for that x? There we go. We're going to divide by 2. So my x is equal to negative 1/2. Do you guys feel good about that? That is one of my potential x values, is negative 1/2. Then, guys, we're also going to say x minus 5 is equal to 0. So I'm going to set this one equal to 0, and I'm going to set that one equal to 0. Now, this one is super easy to solve. So, Weston, can you help me out with this one? How are we going to solve for this guy? Oh, we just add 5, right? Because we want to solve for the x, so we're going to add 5. So that becomes x is equal to 5. So those right there are my two solutions. Do y'all feel good about that? So guys, and remember, when we graphed this, guys, we can check our answers. So we solve for x. Now we can check. Guys, does my solution look like it's about at -1/2 and +5? Are those my two x-intercepts? So guys, you can solve this by graphing. You can solve it by factoring. And guys, I want you to take a look at the factors here. One of my solutions is -1/2. The other solution is +5. So guys, are these related to the factors that we have? Do you see how that's x minus 5 and my answer is x equals 5? 2x plus 1 and it's -1/2. All right, guys, do y'all feel good about that? Awesome. Okay, so now let's take a look at number 1 here. Okay, so do you guys notice we want to factor this. So do y'all notice anything special about this guy right here? Is it in standard form, first of all? Yes. Yeah, it's equal to 0, so we're good. It's in standard form. Okay, now we want to factor it. Is there anything special about this, or can we just go ahead and factor? I don't think these are all visible by 2. They are a number 2, but not on this. It's a perfect square trinomial. Yes, good job, Emiliano. Okay, so guys, this one is a perfect square trinomial. Now, here's the deal. If you didn't recognize that, that's okay. You could still make your x and do the 120 and all that stuff. But guys, so if we take the square root of 4x squared, what's that going to give us? 2x. What's the square root of 25? 5. 2x times 5 is 10. You double that. Do we get 20 right there? We sure do. So what is my actual factored form of this problem right here? 2x plus 5 squared equals 0. Do y'all feel good about that? Now, even if you were not able to recognize that and you just factored it like we did above, you would still have gotten 2x plus 5 squared equals 0. So guys, what this is saying is now we are only going to have one solution. So we are going to solve 2x plus 5 is equal to 0. So now we subtract 5 from both sides, and we have 2x equals -5. Divide that by 2, and my x is equal to -5/2. Do y'all feel good about that? Yes? Okay, if we wanted to write it as a ordered pair, you could also write it as -5/2, comma 2. You could write it either way, all right? So you could write it this way or that way. Doesn't matter, they're both correct. But what I want you guys to recognize, when you have that perfect square trinomial, there is only one solution. So guys, when your factor pairs are the same, there's only one solution. And that actually is going to make total sense, because when we graph this to check it, we are going to go here and say 4x squared. 4x squared plus 20x plus 25. When we graph this, we will see, is my vertex on the x-axis? Yes. So there's only one solution. All right, guys? So what I want y'all to do right now is I would like you guys to go ahead and attempt to do numbers 2, 3, and 4. All right, guys? Number 2, please recognize that is, especially numbers 2 and 3. Number 2, please recognize there is a GCF there. Numbers 4 and 5, are those guys in standard form? They are not. So you are going to have to get it in standard form. Okay, guys? So this one would look like so. And this guy. So you need to get it in standard form. All right, guys? So please, let's do numbers 2, 3, and 4 so that we can attempt to do these in standard form. I really want y'all to work on number 2 first, all right, guys? And then we're going to come back and work. All right, so guys, we're going to do number 2 here real quick. All right, guys, so first of all, you got to recognize you want to pull out that GCF, right? That 2. So we are left with 2x plus x minus 3. Okay, so this is what we're actually factoring here. So we're going to take a look at this. We are going to, so we want to find the factors that multiply to negative 6 but add to 1. That should be 3 and negative 2. So this is really 2x squared plus 3x minus 2x minus 3. Okay, so we are going to take our factors here. So we can pull out an x, and we are left with a 2x plus 3. And we can pull out a negative 1. And we're left with a 2x minus 3. All right, so then our final factors would be x minus 1 times 2x plus 3. But we can't forget that 2 that we took out originally. So that's equal to 0. All right, guys, so this would be our factored form. Do y'all feel good about that factored form right there? Then we set each of these individually equal to 0. So x minus 1 is equal to 0. I love these. These are so nice, aren't they? Because you don't have to do, it's a one-step equation. It's x is equal to 1, which is so nice. But the 2x plus 3, this one requires a little bit more work. We set 2x plus 3 equal to 0, but not that much. It's just 2 steps because we have 2x equals negative 3. So we just have to divide by 2. So my x is equal to negative 3/2. Do y'all feel good about that? So guys, I'm asking for the solutions from the factored form there. Do y'all feel good about that? Okay. Now, so that would be our solutions here. Now, on number 3, and guys, don't forget, you can graph it and check. So you can go ahead and you can type in y equals, ooh, I got to zoom out a smidge. Y equals, I'm going to type in my graph here, 4x squared plus 2x minus 6. I'm going to hit graph, and I see, yep, that's about negative 1.5, and that's 1. So those two solutions actually match what we got here. Does that make sense, guys? Always graph your equation and check it. Always, always, always. Okay? Now, let's take a look at this guy here. We subtracted our 5 to get it equal to 0. So, guys, how am I going to factor this? Well, can we take out a GCF of this?
No. Yes.
What do they both have in common, Eva?
An x.
An x. So if I take out an x here, what am I left with? 9x minus 4. So y'all, my factored form is actually going to be x times 9x minus 4 equals 0. So this one didn't turn into two binomials. It was just an x and a 9x minus 4. Do y'all feel good about that? So now, this is really easy. You set x equal to 0. Y'all, that's one of your solutions. I set one of my factors equal to 0. Yay. Okay? Then I just have to do the other one. 9x minus 4 equals 0. Now this is a2-step. So we're going to add our 4. So we have 9x equals 4. We divide by 9. So x is equal to 4/9. So those are my two solutions. Do y'all feel good about that? Does that make more sense there? Yeah. So that's why we added that one in there, because sometimes that does happen. And you want to check yourself. Now 4/9 is like a 0.44444 repeating. But I still want to take a look here. So I'm going to say 9x squared minus 4x. Now this is a little bit harder to see. So I'm going to zoom in a smidge. So guys, you see how it goes right through 0, 0 and kind of like 0.444. So it makes sense. It's that positive 4/9, okay? All right, for number 4, we have this lovely guy right here. So guys, how can we factor this? Two numbers that multiply to 5 but add to 4. Is that possible?
No.
Guys, this one cannot be factored. You cannot complete the x All right? You cannot complete the x with any numbers. Also, guys, if we graph this, you will see why. Y'all, if you go to y equals, you do x squared plus 4x plus 5. What is true about this graph? Does it ever cross? It makes sense, right? So this one, there are no real solutions. There's only imaginary solutions to this one. All right? Now, guys, there are times where when you graph it, it crosses, but they're irrational numbers. They're not at rational numbers, and so you still can't factor it. So, guys, if you can't figure out what the factors are, just put it into y equals and see if it makes any sense. Okay, so there's no real solutions. Do y'all feel good about that? Okay, finding it from your factors. Yes, ma'am.
If it's like a no solution, would you get it wrong if you just put no solution, or would you have to put no real?
I would probably not count it wrong.
Okay.
Because we're not doing imaginary numbers this year. But just that's what it means, is that there's no real solutions. Does that make sense? Yeah. Okay. So no real solutions. But no, I wouldn't count it wrong because you did all the work to get it right. Does that make sense?
Yeah.
All right. Okay, last thing that I want to go over with you guys today, all right? And then I'm going to let y'all get to this, okay? I want to connect your factors with your solutions, okay? So on these over here, what you guys, I hope you noticed, is like 2x plus 5, my solution was negative 5/2, right? It was the opposite sign, and you divided that constant by the coefficient. Here it was the same thing. X minus 1 was one of my factors. My solution was x equals 1. 2x plus 3 was one of my factors. My solution was negative 3 over 2. Does that make sense, you guys? So I want us to connect our solutions with our factors. So guys, let's say you are just not great at factoring. All right, guys? You can actually use your, so on this case, on page 3, we were using our factors to find our solutions. So guys, on page 4, what I want you guys to do is I want you to use the solutions to find your factors, because you can go back and forth each way. So guys, on these particular problems, I want you to actually find the solution by graphing first. Okay? So we want to find the solution by graphing. So we're going to go to y equals 3x squared minus 5x minus 2. Now, since it's already equal to 0, we don't have to do anything special. So we're going to go 3x squared. I'm going to hit graph. Awesome. I see there's 2 solutions. So I'm actually going to go back to my y equals and type in y equals 0 and y2. And then, guys, I'm going to calculate my intersection. Okay. So guess. Okay. First curve, second curve. Okay, my intersection here says that it's at negative 0.33333333 repeating. So one of my solutions I just got from the calculator here is negative 0.333333 repeating. Cool. All right. We want to rewrite that as a fraction. If you cannot rewrite it as a fraction, it does not have factors. All right, guys? So I'm going to get out of here and I'm going to say negative 0.33333333. Even if you don't know this, guys, you want to go math, enter, and it turns it into the fraction for you, which is negative 1/3. So I'm going to rewrite this guy as x equals negative 1/3. So that is one of my solutions. Do y'all feel good about that? All right. Now my other solution, second trace, it looks like it's a whole number. First curve, second curve. My guess, I'm going to scroll over to my solution there. And my intersection is at 2, 0. So x is equal to 2. So I have 2 solutions. Do y'all feel good about that? So I just got my solutions through graphing. Okay, that's step 1. Now, I'm going to write my x-intercepts as x equals a number. That's step 2. And you want to make sure you rewrite all your decimals as fractions. If you can't rewrite it as a fraction, that means it's not possible to factor. So you have to rewrite it as a fraction. Then we're going to rewrite both equations to where they equal 0. And this is super important. We want all whole numbers when it's equal to 0. Okay, guys? So we're gonna rewrite this guy so that it's equal to 0. So guys, how would I get this equal to 0? What do I need to do? I'm going to add 1/3. Are you guys okay with that? Because that's going to cancel this out. But if I add 1/3 to the left, I got to add 1/3 to the right. So now I have x plus 1/3 equals 0. So then, now I want to make sure I don't have any fractions. So y'all, what can I do to get rid of my fraction there? I'm going to multiply everything by 3. And I'm left with 3x plus 1 is equal to 0. And guys, this just gave me one of my factors, 3x plus 1. All right? This other guy over here, we had x equals negative 2. So guys, one of my factors is x equals negative 2. I'm going to subtract 2 from both sides. So I have x minus 2 equals 0. So that right there is my second factor. So guys, my factored form would be 3x plus 1 times x minus 2 equals 0. So y'all, I can use my solutions to find my factors. Isn't that cool? You can use your solutions to find your factors. On page 3, we were using our factors to find our solutions, but you can also use your solutions to find your factors. All right, guys? Do y'all feel good about that? Okay? Now, a way that you can check yourself that is really, really cool is, guys, you can go here, and if you type in your original equation, 3x squared minus 5x minus 2, and I type in each factor one at a time, 3x plus 1, and I hit graph, it should go through my original graph at the solution point. Does it intersect perfectly at the solution? It does. So that's my first factor. If I type in my second factor, x plus 2, this one should also, but I did that wrong. What is my factor? It's not x plus 2. What is it supposed to be? X minus 2. Whoops. So guys, does this intersect at one of the solutions? No, because I typed in x plus 2. It's supposed to be x minus 2. When I hit graph, it intersects perfectly at one of those solutions, right? That second solution there. So guys, the reason why that is super nice to see is because, guys, sometimes when you're on a test, it'll give you this right here, and it says, give me one of the factors. So guys, you could literally type in your equation and type in one of your factors, and it should intersect at the y-axis, okay? So you can check by typing in each factor and making sure it crosses at the solution. So it should cross at the solutions. All right, so the factor should cross at the solutions. So you can check by typing in each factor and it should cross at the solution. So y'all, this is really just a way I want you guys to understand we can start with the factors and find the solution, or we can start with the solutions and find the factors. Does that make sense, guys? You can go back and forth between both of them. So what I want you guys to do is on number 6, is this in standard form? It is not. So we need to subtract our 5x. I'm going to do this one with you guys, and then we're going to get to work on our stuff. So we are going to have 2x squared minus 5x minus 3 equals 0. Okay? And so we are not going to factor it. All right? We are going to find the solutions in the calculator. So we go here. We're going to find them. So we're going to say 2x squared, minus 5x again, minus 3. I'm going to graph it. There we go. So I have two solutions. I'm going to find my two solutions here. Okay, I'm going to go to y equals 0. Second trace, intersect, 1, 2, 3, negative 0.5. So it looks like one of my solutions is negative 0.5, or I'm also going to call it negative 1/2 is one of my solutions. All right, and then the other solution, that looks like a clean solution. I will double check. 1, 2, and then my guess, I'm going to scroll over, and I get that my x is equal to 3. So I have two solutions right here. And now that I have my solutions from the graph, I can go here and say, cool, x is equal to negative 1/2. Sorry about that. So I'm going to add 1/2 to both sides. So x plus 1/2 is equal to 0. Multiply everything by 2. So one of my factors is 2x plus 1 is equal to 0. That's one factor. My other factor is significantly easier. X equals, that's supposed to be just a 3. But I'm going to subtract 3 from both sides. So we have x minus 3 equals 0. So my two factors are 2x plus 1 and x minus 3. All right? And that is equal to 0. So my two factors are 2x plus 1 and x minus 3. So you can find your factors from your solutions, or you can use your solutions to find your factors. All right? Or you can also find your solutions from your factors, like we did on the other page. Do y'all feel pretty good about this? I want you to practice on numbers. Oh, I did 5, 6, and then for some reason it's 5 and 6 again. So if you guys want to cross that out, that's supposed to be 7 and 8. You guys can check yourself there, and then we're going to get to work on our homework. All right? And so I'm going to throw these up here just so you guys can see the answers to numbers 7 and 8. We have our solutions, and we have our factors. Once we find our solutions, we're able to find those factors.